Right then, so hello internet, I suppose. This is going to be my first YouTube video. I hope it goes well. And I'm going to be working through this maths paper I found. It's Mechanics AS, and yeah, I'm just doing this for revision purposes really, and to practice talking through questions because apparently it's supposed to help you get a better understanding what you're actually doing, which, that sounds like a good thing to do. So let's start. At time t equals 0, small stone is thrown vertically upwards with speed, blah 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 blah. To find the value of t. So this looks like suvat to me. So let's draw this small stone. We're modelling it as a particle, and it's moving upwards at the speed of 14.7 meters per second. And point A, okay. Time t equals t, the stone passes through A, moving downwards. Okay, find the value of t. Right, that seems fairly simple. So we know that, first of all, should we say, we'll say up is positive, so u is going to be 14.7. Acceleration, it's freely under gravity, so that's going to be minus 9.81. S, and then this is the only really hard bit about this question. It wants you to spot that when the stone passes back through A going downwards, the displacement is going to be 0. Then what else have we got? Oh yeah, then we want to find time. So what formula is that? S equals half. Is that it? No, S equals ut plus half at squared. And then, where's my calculator? Right. So if we just sub in the values, we get, so that's 0. I'm going to take out a factor of t here, just to simplify things a little bit. 7, then add a half minus 9.81. Just do that on my calculator, so that is minus 4.905 t, and then that's fairly simple to solve. We can Right, sorry about that. My mother just came in, so there'll be a slight jump in the recording if I've cut it correctly. But where was it? Oh yeah. So this is fairly easy to solve now. You've got 4.905 t equals 14.7. And then you just put that in your calculator. 905. There we go. Oh, so t. It's 2.996, which I'm just going to say is equal to 3 seconds. Okay, I mean, it's 2 marks. That took us longer than 2 minutes, but in an exam I wouldn't be talking through it, so it's fine. Right. Total distance travelled by the stone in the first 4 seconds of its motion. Okay, so that builds on the first bit, because we already know that for the first 3 seconds it's gone all the way up. So for the first 3 seconds it's gone from A. Actually, let's draw a diagram here. So it's gone up. That's point A. And then it's come back down again. And this is like a total of 3 seconds. And then it's travelled some distance here in 1 second. So we want to find this distance here. And then we want to find that distance there. Okay. It's fairly simple suvat, I guess. So u from the other one, I think it was 14.7, a minus 9.81. Oh, okay, yeah, that makes sense. So v is gonna, when it's at the top here, its peak, this little point, v is gonna be 0, and yeah, that's what you need to spot, I suppose. So, and we want to find displacement. So what formula is that? Oh, v squared equals u squared, add 2as. What was it, u squared? And we know v is 0, so v squared 0, u 14.7. What's that? 216.09. Add 2as, that'll be minus 19.6 s. Oh, and then we just solve for s. So s is going to equal, there we go, 11.025 meters. Right, so if that 11.25 if that is going to be this little distance here, this one, and then it's going to travel up there, and then it's going to come back down again. So the total distance in 3 seconds is going to be 11.025 times by 2. What is that? 22.5? I think, I hope. And right, so then it's going to be, then we're going to have to do that again. So this time u is going to be minus 14.7, a equals minus 9.81. We want to find s, and t equals 1. So it's the same formula? No, it's not. It's s equals ut add half at squared. So s is going to be equal to, you just put all that in your calculator, and hopefully you get the same as what I do. Right, that should give you minus 19.605, which, yeah, that many meters, and since that's displacement, but it's, yeah, we get a negative value, but that's fine, because we know, as it's going downwards, we've said that upwards is positive, so, the distance travelled is still going to be 19.605, so it's going to be, this number here, 22.5, add 19.605. I don't think I've explained that very well, but it's fine. Right, that's 42.1 meters. It is 42.105, but I'm going to leave it at that. 42.1. Now, there is a part C. State one refinement that could be made to the model, apart from air resistance. Refinement that could be made for a model. So we're already modelling the stone as a particle. Now, I am a physicist, so I do want to say that gravity is not always going to be 9.81 because it's not uniform. I think I'm going to have to go with that because I'm not quite sure what else. I know when I look at the answers I'll be kicking myself, but it doesn't matter. So I guess I'll just say take a more accurate value for G as gravity isn't uniform. No, it's a bit messy, but it's fine. Alright then, next question 2. So we've got particle P along a straight line, its velocity. Oh, okay, right. This is very obviously a variable acceleration question. So we're going to have to do some integration or differentiation or whatever. Right, so find the acceleration of p at time t seconds. Acceleration. And we have velocity, so we are going to have to differentiate, I'm pretty sure, because the way I think about it is if velocity, units for that is meters per second, and acceleration is. Oh, get rid of that. There we go. Meters per second, and whenever you take the derivative of something, so you will always take away 1 off the power. So, and as you can see here, to go from -1 to 2, you minus 1. Sorry, to go from -1 to -2, you take away 1, which is the same as doing the derivative, which is how I think about it, how I remember it. Right, so, yeah, so we do the dv over dt. Oh no, so we should probably, actually no, we'll just do that. Dv over dt equals, or is that going to be 10 minus 2t? Right, so at time t, with acceleration at time t seconds. Wait, have I read this wrong? K is a constant. Oh, no, wait. Wait, the acceleration of p at time t seconds. Oh, at time t seconds the velocity is that, so I think that's just it. So acceleration equals 10 minus 2t. I think that's just it. I hope it is. Guess I'll see when I check the answers. Right, particle p is instantaneously at rest when t equals 6. Find the other value for t when p is instantaneously at rest. So, when it's instantaneously at rest, we know v is going to be equal to 0. So 0 is going to be equal to 10t minus t squared minus k, and since we're given t equals 6, we can say that 60 minus 36, oh no, I've already squared it, I don't need that sign again, minus k, so what is that? K is 24, I think. Right, so now we know that k is 24. Find the other value for when p is instantaneously at rest. We can then use our equation here. 10t minus t squared minus 24. No, it's a quadratic. I hope this factorises. I think it does, yeah. So we have t minus 4 and then t minus 6. And since we've already used the t is minus 6 one in this, we've already had t equals 6 when it's at rest, so that means the other value for t is going to be t equals 4 seconds for the when it's also instantaneously at rest. Then we've got find total distance travelled by p in the interval 0 t equals 0 to t equals 6. Right, okay, it's maybe a little tricky, as I feel like this is leading on from part B. If we know that the particle is at rest, instantaneously at rest at 4 seconds, that means that the particle could have travelled for 4 seconds, and then if it's at rest at this point, then it could have then changed direction and then gone back. Which I'm trying to think, was it displaced? No, it's total distance travelled. Okay, so it looks to me like this is just we're gonna have to integrate this. I think we're gonna have to integrate that and then use it twice. So what have we got? S equals the integral of 10t minus t squared. 10t minus t squared minus 24 with respect to t. Oh, great. What is this? T squared, so that's going to be 5t squared minus a third t cubed minus 24t, and then we want to do it between, I probably should have put it up here, 0 and 4, and we know when it's 0, basically we don't need to sub that in because there's no constant term in here, so it doesn't matter. So I'm going to sub in 4 into that equation I've just got here. I hope this is right. That doesn't look right, it isn't promising. Got minus 37.3. Have I got wrong anywhere? Can't see it if I have. I mean, it might just be that the particle is going to the left first, so displacement is going to be negative. So then, if we then take that absolute value of it, then displacement is going to be 37.3. I might have got that one wrong, but I'm going to carry on anyway, just try and pick up some method marks. So, right, we know that's the displacement at that time, so then I want to do it again between 4 and 6 seconds, because 6 is our upper limit anyway, and we know it's changed direction at 4 seconds. So I'm going to do the same thing again. What should be square bracket there? So we're going to have 6 and 4. And then we're going to have some big calculation here, which I guess I'll write it down, why not? So we're going to have 5, 6 squared minus 1 over 3, 6 q minus 24, 6, and then we're going to minus all of 5, 4 squared minus 1 over 3, 4 q minus 24, 4. There we go. Right, and what is this going to be? So the square is 36. Probably got this wrong anyway, so it doesn't really matter. Oh, I'll just use my calculator. It's easier. 72 minus 24 times 6. 144. I'm going to minus all of 4 squares, that's 80. 4 cubed, what is that? 2 to the 6, 64 minus 1 over by 64 over 3. 24 times by 4. I should do that on my calculator. Minus 96. So then we get S is equal to, I'll just put all that in my calculator now. I'm not doing that in my head because what's the point? 18. 6. Right, that gives me 4 over 3. I don't like that number. Doesn't matter. So the total S, I mean that shouldn't be S, that should be distance, but kind of breaking maths, but it's fine. What did we have before? 37.3 recurring, so we're gonna have 4. 3 out 37.3 recurring equals, what was 37.3 recurring? It's a fraction. 112 over 3. 116 over 3. 3, which is about 38.7. Yeah, that doesn't look like the right answer, but when I watch this video back, I'll see, and I'll know what I was thinking at the time because I'm talking out loud like this, which is good. Yeah, it's that question. Oh, there's a lot of paper for that. Oh my goodness. That's a lot of words. Right. What have we got? We've got a pulley system, so this is going to be resolving forces. Ball P of mass 2m is attached to one end of a string. Okay, that's there. See that? A string passes over a fixed pulley. System is held at rest, so it's your basic pulley system. Hanging parts of the string vertical with P. That's like 2h above the horizontal. Okay, so it hasn't given us. It's all algebra. It hasn't given us any numbers. System is released from rest. In the subsequent motion, Q does not rebound when it hits the ground, and P does not hit the pulley. Okay, so basically that all that's telling us is that when Q hits the ground, that it's going to stop completely. So that when Q, I think that means that when Q travels h amount of distance, P is going to go up h amount of distance and stop immediately. I think that's what that's telling us, and P does not hit the pulley. Oh, so that's basically just telling us that this length here, so from here all the way up to the top, is going to be less than h. Wait, no. Yeah, a little less than h. Okay. I mean, that's kind of obvious looking at the diagram, but they just made it clear in the question. Right. Write down an equation of motion for P. Okay, so this is resolving forces. So we're going to use F equals ma, Newton's second law. What is it for P first? So the force is going to be tension. Right, so where's this going to be going then? Tension is holding it up. Wait, what's it mean? I'm not happy. Does this question mean write an equation for motion of P as soon as it has been released? I think it does. I think it does mean as soon as it's released, so that means that first of all, mass times by. Right, just thinking here, so we know Q's heavier, so Q's going to go down. That means P's going to go up, so that means T is going to be greater than 2mg. So, does that, I think the correct equation is T minus 2mg, because if G is going down, T is pulling it up, basically. So T is the only force pulling it up, and then G is pulling it down. And if it's going to be going up, then T is going to be greater than 2mg. Yeah, that makes sense. And then it's going to be ma equals ma. Oh no, 2ma, because the mass is 2m. So that's going to be the equation for, what was that, P? Yeah, P. For P. Right, so then we're going to do the same thing with Q. So this time we know that Q is going down, so we know that 5mg minus T equals 5ma, because we've used the same variable for T as well, because it's a pulley system, and that's kind of the point of these questions, that what do you call it? The tension's uniform throughout the strings, so it's the same. Right, so what's this next part? Should be there. Find in terms of h only the height above the ground at which P first comes to instantaneous rest. Wow. So, thinking about this, when P comes to instantaneous rest, we mentioned earlier that Q does not rebound, so when Q hits the floor here, its speed is going to be 0. And that also means that since Q is pulling P up, and once Q stops moving, P is going to stop moving. So P is going to travel some distance h here, and then it's going to stop moving. Wait, some distance h? No, that can't be right. No, that's definitely not right, because then the answer would just be 3h, because you'd add that and that. Huh. Right then, so it must mean... I'm trying to think about this, and I think it means that it's going to travel h distance here, and then at this point, it is going to stop. It won't stop immediately, and what's going to happen is t will suddenly go to 0, so that means it's going to stop accelerating upwards, and then it's still going to travel some distance up here until it stops, and then it'll fall back down again, and then it'll lie at rest here. So I think that's what the question's saying, because if you think about this, then once Q comes down, yeah, I don't know what I was saying earlier, because when Q comes down, P is going to go up, but P won't immediately stop at this point there. He's still going to travel a little bit further up, because the string will just stop going taut there. So first of all, for the equation of motion, we're going to have 2h add h is going to be when P has T acting on it. Right, so it looks to me like we're going to have to use these two equations. Change colour here, there we go. So we're going to have to use these two equations, and we don't really want t, because t is going to equal 0 at this point there. No, there. There we go. So, basically we've got to solve these simultaneously. It should be fairly simple. I'll solve it in terms of t. So t, for the first one, we have t equals 2ma add 2mg. For the second one, we've got 5mg minus 5ma equals t. So then if we solve these simultaneously, we get 2ma at 2mg equals 5mg minus 5ma. So do a bit of rearranging and simplifying. What have we got here? 7a, we divide through by m first, and then you can just rearrange that. Over equals 3g, so that means a equals 3 over 7g, and we can put that in our calculators, and that comes to approximately 4.2 meters per second. Oh, meters per second, because that's acceleration. So we've just found out the acceleration when it's there, when the P's there. So that means that it's going to... Oh, I don't know how to explain this. So it looks to me like we've done all the forces bit, and since acceleration should now be constant, then I think we can just use suvat now. Right, yeah, so the value for A going upwards. So at this point, right, let me just write in a different colour. So at this point, hey, that's a bad colour. So the value for A is going to be about 4.2. However, that's not the final acceleration, because you've still got G acting against it. So it's going to be, the final acceleration is going to be at, I don't know how to write that now, I'll just label A. So A final, that little F stands for final, is going to be G minus 3 over 7G. Oh, 3 over 7g. Oh, which is just going to equal 4 over 7g. There we go. Then it looks to me like we can just use suvat now. So AF, yes, we just worked out 4 over 7g. What do we have then? We don't know its initial speed or anything. What else do we actually know? Oh, well, we know the final velocity is going to be 0. We could say... No, we can't really say this. Can we say displacement 0? I don't think we can. Where is it here? No, we're going to have to do something else. What else do we do? So it's definitely not time. And U, we don't know what U is. I mean, could we find U? I think we could find U. Well, wait a minute, have I been doing this wrong? So, I'll stick in blue. So for Q, right, so for U, if we find U, try and find the initial velocity when P is suddenly being acted upon by this value for G, then when Q goes down and hits the floor, its velocity here will be the same as P's velocity there. So I think I've jumped the gun a bit here, and we need to do suvat for Q first. So for Q, and since we know the acceleration of Q is going to be, as you can see at this point here, worked out earlier, that's for Q, right? Yeah, that's going to be the acceleration. So A is going to be equal to 5m, and then what was A again? I worked it out. Oh, 3 over 7g. U equals 0. S equals, what was it? H? I think it was H. And then V equals, that's what we want to find out. So, what equation is that? What equation is that? Yeah. V squared equals U squared. Add 2AS. V squared equals. Alright, this is a bit awkward. I think I've done this wrong actually. Doesn't look like a very nice answer. 2 times, right, what's 5? That is 15 over 7g. Oh, 15 over 7mg times by h. What is that? 37mg h. Right, that's not very nice. Right, that doesn't look good, but I'll continue, see if it simplifies. It might do, but you see the problem is, we want it in terms of h only. Oh no, because we need to get rid of m somehow. Oh wait, oh no, it's not going to be. That's not the acceleration. No, I'm being silly. That's just the acceleration because 5m. That's the force of it. That's not the acceleration of it. That's the force. Oh, okay, so there is no m, so there's no m here. And that's just going to be 3 over 7g. So this will be 6 over 7, and then this will be 6 over 7. There we go. Okay, that's right. And then, right, here we go. Now we can do suvat. So U equals root 6gh over 7. A equals whatever we did before in the green up here. 4 over 7g. 4 over 7g. OV equals 0, and we want to find S in terms of H. So we're going to have V squared equals U squared, add 2AS, and that works out nicely. So we know v squared is 0, u squared is just going to be 6gh over 7 because we get rid of the minus sign. Add, 2 times by 4 over 7 is going to be 8 over 7g, and the s. Right, so we're going to have 6gh, we're going to have that minus equals 8 over 7g. So there we go. Divide by g times, they're both over 7, so it's just going to be minus 6 over 8h is going to be the distance travelled. And what have I done here then? Have I? Q's going up. Right, I see what I've done here. Because I have just said acceleration is working downwards and velocity is working upwards, so one of these should be negative, basically. So I'm going to say if it... wait, let me change back to blue. So acceleration should be negative. Great, I made a mess of this. A equals negative 4 over g. So that means this would be negative, and then this would be positive, so I can get rid of that. Right, so that's h. So the total distance is 6 over 8h. Add 3h from what we worked out earlier, that bit, because it travels that distance there. And then it travels... Wait. What was the question again? Height above the ground, yeah. So it's going to be this 5h, this h, and then add that little dotted section here that we just worked out is going to be the final distance travelled, which is 3 add 6 over 8. Brain's been a bit slow, 30 over 8h. I think that's it. I'll just check on the calculator because I don't want to get it wrong after all that work. No, it's 15 over 4. There we go. Right, that's that big. That was 7 marks, right? Yeah, 7 marks. Gosh, that's a big question. I hope I've got that right. I'll check it later. See if I have. So what have we got? State one limitation of modelling the balls as particles that could affect your answer to part B. State one limitation. Right, so, well, we've already said air resistance is modelled as being negligible, so we can't say that again. Modelling the balls as particles. I'm trying to think in terms of mass, but we have their mass. Are we given that? Is that an assumption though? Do we assume that? We assume they're... I think... Oh no, I'm not actually sure. I probably should have revised this. So one limitation of modelling the balls as particles that could affect your answer to part B. Well, a ball in real life, well, I'm just going to have to mention air resistance. I can't think of anything else. Balls in real life would be affected by air resistance. So, answer to part B would be smaller. There we go, can't worry. Right, well, I saw there's a part D. What's this last little bit? State how this would affect the acceleration. Oh, in reality, the string will not be inextensible. State how this would affect the acceleration of the particles. So by assuming that string is inextensible, we've assumed that the tension is the same all throughout the string. And also when Q... Oh, so basically, Oh no, never mind. What am I talking about? So in real life, if Q was to suddenly fall, if the system was suddenly released from rest and Q fell, there would be a slight little pull in this little string here. So that means A would be slightly less. Right, so is that what the answer wanted? Oh, A would be slightly smaller. Station would be slightly smaller. There we go. I think, yeah, that's it. Right, so, yeah, that's the paper. I think it was just 3 questions. Was it? Yep, it was. How many marks? 30 marks. So I'm not sure what I'm going to do. I might do another YouTube video marking it, going through it, because a thing to note is that if you're watching this to try and learn something, I am quite frequently wrong, so my answers may not always be right. So don't assume that. I mean, this question 1, I should have got that right. I hope I have. Question 2, thoughts are that number, the 38.7, that looks a bit dodgy. That might be wrong. I don't know. But yeah, I'm not sure what I'll do. I might do another YouTube video marking it, but I'll see. If I mark it and then I've only made like 1 or 2 errors, I probably won't make a whole video about that because that'd be rather boring. So I think I'll just leave it there. I'll save this PDF. There we go. Right then, so I think that'll be it now.